Okay, we're going to solve 3-14. This is a fun one. We're going to solve it two different ways. Or I'm going to show you how to solve it two different ways. One's using Excel, which will actually be the quicker way to do it. So the problem we got is we know we have a gas that is composed of methane and ethane, and the specific gravity is 0.75. So that's 75% the weight of air. Remember, it's STP. What is the weight percent, volume percent of methane and ethane in the picture? So percent weight, percent volume. So step one, we need to set up this calculation. Is we know the specific gravity of is based off of the weight of water, or I mean air at standard temperature and pressure. So if you go into the appendix, you'll find the molecular weight of air to be 29. So the apparent molecular weight of the mixture we're looking for of C1 and C2 would be 0.75, which is our specific gravity, times 29. So that value, we can do the math there. That value should be 29 times 0.75. That will be 21.75 is our mixture molecular weight. So now we got to come up with our compositions. So we can call these, I guess, Y sub j. Remember, this is the volume concentration if we're assuming an ideal gas. So we have some value here, some for methane, some value for ethane that we're trying to find. Here's our molecular weight of Y sub j components. So the molecular weight of methane is 16.04, ethane is 30.07. So we see this value has to lie between those two values, right? It's some mixture, it's heavier than methane, lighter than ethane. So this value, we can call this, say, X and Y. So this value times that value is going to give us the mixture. And so we would get some values here of, let's see, y times m. You would get some value here, which would be x times 16.04, y times 30.07. And then you want to add those two together, and that should equal to this 21.75, if I'm right. So x times 16.04 plus y times 30.07 should equal 21.75. So this is one equation with two unknowns, right? So we need one more equation. The other equation is x plus y has got to equal 1, right? Your compositions have to add up to 1. So that's your other equation. So we could solve for that. Say solve for x, x equals 1 minus y. We plug that back into here, so we get x times 16.04 plus 1 minus, oops, I got it backwards here. I meant to do that this way. Y equals to 1 minus x. So then we get it into x. How's that? 30.07 equals 21.75. So now we can figure this out with algebra, and we'll come out and get the answers. But I want to show you another way you can solve this equation. Back to our spreadsheet. So, well, I'll come back to that in a minute. So we had started a spreadsheet in one of the earlier problems that we had. And here it is. So here's our components, methane and ethane, C1 and C2, if you will. We're trying to find these volume fractions and then ultimately the weight fraction. So let's start filling in some values here. We don't know these values yet, right? But how about air? We want to know we know the molecular weight of air is 29, the specific gravity is 75. So our mixture would be equal to this times that. That's going to give us 21.75, which I've already done right here. So now we're trying to make this value, the summation of these two cells, equal to that. So how do I start filling this in? Well, step one, let's just throw a random value in here, 0.1, and then I know from this equation that y equals 1 minus x, right? So this cell is going to equal to 1 minus this guy, right? So there we go. And these should add up to 1 if you do the summation. I can throw that there just for the sake of putting it there. So those have to equal 1, right? You can't have more than 100% volume. So now this is the volume fraction times the molecular weight. It's going here. So this value times that value. This I already put in from Appendix A. Then I copy that down. So here these are. Now, the apparent molecular weight is the sum of these two guys. So sum of those two. There we go. So 28.67. So 28.667 is bigger than this, right? So we need to make this value. Well, I could come here and keep guessing values until I got it. You know, there's closer, 0.4, 0.5, 0.6. Okay, see, I've gone too far. I can keep guessing. That's one way to do it. But there's a faster way to do that in Excel. So if you click on the Data tab in your Excel and you go to this thing called What If Analysis, first thing, let's select, here's the guy we're trying to figure out, right? We want it to match that value. So if I hit Goal Seek in the What If Analysis, you may have to load the Analysis tab in your Excel. So what we're getting is set the cell. I want to set this to a value. I want it to equal this value. So type it in, 21.75 by changing cell. So this is the one I want to manipulate, and I'll select this value. So there we go. So what that's going to do, that's going to keep putting values in here until this value matches that value. That's called goal seek. So let's do it. Click. Here we go. It matches 21.75, and here's the answer to our question. So the methane percent, if I go back to the original question here, so C1, this X here, the composition is 0.593. The composition of the other one is 0.407, more or less, if we round it. And then we want to get the weight fraction. So the weight fraction is this value divided by the apparent molecular weight. So if I come back over here, I can do that. So that equals to this value, actually it's y sub j times m, my fault, over the apparent molecular weight, which is this value. If I hit F4, I'll pull my keyboard in here. If I hit F4 up here, that will lock that with the $sign. That will lock that to this cell. So when I copy it down, it will keep it maintained. So there we go. And you can see it maintained that cell. So the weight fraction of these two components is 0.437 and 0.563, more or less. So here is the answer to your problem. Two different ways of solving. One, old school algebra. If you solve this, you can come up with the answer, or you can use Excel and find the same thing.